Hi, this is Jason Baker, and welcome back to our lecture talking about serverless and Lambda functions. I wanted to spend a little bit of time talking about some of the additional features and considerations that you need to have when working with Lambda functions. First of all, when you're working with Lambda functions, you can set up environment variables. And the way to think about environment variables in the context of Lambda functions is is that these are a way to sort of inject parameters into a Lambda function. So the environment variables allow you to parameterize the Lambda function, which is really useful, right? Because you can provide the Lambda function with with different endpoint addresses that the Lambda function might need to be able to access, or the name of different resources that the Lambda function will use. And it lets you sort of use a Lambda function or sort of reuse a Lambda function in a variety of situations just by passing in a different set of parameters. And environment variables are key value pairs, and you actually define them as part of the Lambda function configuration. When the Lambda function is invoked, the environment variables are passed into the Lambda function environment, and the code in the function can then read the value of those environment variables while the function is running. There's really no limit on the number of variables that you can create, but the total set of variables must be less than 4 kilobytes. When you're creating Lambda functions, you can also assign a version to the function. And what the version does is it basically sort of creates a snapshot of the Lambda function, both the code in the function and the configuration of the Lambda. Now, each time you invoke a Lambda function, you're actually invoking a version of that function. And if you don't specify the version, then AWS will default to using the latest function version. You can see in this slide that you can, when you're referencing a Lambda function, you can either qualify it with a version, such as the latest version, or you can just simply state that you want to invoke the Lambda function, and then it's an unqualified reference, and AWS will invoke by default the latest version. When you're creating Lambda functions, you can specify a version that you want to associate with that function. So you can assess, so you create a new function, you can say, this is version 2 of my Lambda function. The advantage of creating different function versions is that it allows you to support an environment where you are invoking multiple versions of a function concurrently. And you might do that to maintain backwards support in an API, right? So as you develop and add new functionality to your API, oftentimes you'll need to support the previous version or two of the API so that clients that are dependent on that API don't automatically break when you push out a new version because they're sort of pinned to a previous version of the API. Along with versions, you can also use aliases. And aliases give you a way to essentially point to a specific version of a Lambda function. You could imagine, like, if you had a Lambda function and it was version 3, you could also create an alias called production and point that alias to version 3. And then when you release a new version, let's say version 4, you can update the production alias. The advantage is that if you have other services or functions that are referencing your Lambda function, those functions don't need to specify an exact version number. They can just reference an alias, and then behind the scenes, you can repoint that alias at a specific version. So as you sort of update versions over time, you don't have to go out to all these other services and then update the actual version number of the Lambda that those services are pointing to. When you execute a Lambda function, you have to be aware of all the default limits that AWS imposes on that execution. Um, and this slide is actually slightly out of date because today the maximum execution duration is now 15 minutes. For a long time, it used to be just 5 minutes, but it's much longer now. The request body payload is 6 MB. The number of concurrent executions per region is 1,000, meaning that by default you can invoke up to 1,000 Lambda functions concurrently in any given region. And of course, some of these limits can be updated. So, for example, the number of concurrent executions per region that can be updated depending upon your needs. The maximum execution duration cannot be updated. There's also a deployment package size. So the you can't create functions that are more than 250 megabytes in size. That would be a truly massive Lambda function, and one where you're probably packaging in all kinds of third-party dependencies. But generally, you just would be very rare to see a function of that size. There are cases where you create a Lambda function and you want that Lambda function to be able to access resources that live inside of a VPC. For example, you might want your Lambda function to be able to access a service that's running on an EC2 instance. Or maybe you want the Lambda function to be able to access a MySQL database running on an RDS instance within the VPC. Uh, this is a little bit tricky, of course, because the Lambda function is not running within the VPC. The Lambda function is basically running as an internet service. It's running, somewhere within the AWS ecosystem. It's not running within your VPC. And of course, because it's running out somewhere on the internet, by default, it's not going to be able to connect to your RDS database that's running in a private subnet. So um, what you need to do to connect the Lambda function to a resource running in the VPC is you can actually configure the Lambda function and specify a VPC and security group that it will use. And what it does essentially is AWS will set up an elastic network interface for that function. And the function will actually get a private IP address within your VPC. It will use that private IP address to communicate with other resources running within your VPC. So this is what allows a Lambda function to talk to something like an RDS database. Now there are a couple issues with this sort of configuration. Every single Lambda invocation will require a private IP address within your VPC. You could imagine a scenario where you might have like hundreds or even thousands of Lambda functions being invoked concurrently in a heavily used application. And each one of those Lambda invocations requires a private IP address. you need to make sure that you have enough private IP address space available within your VPC. Otherwise, your Lambdas could use up all the IP addresses that are available, and that could potentially throttle the future invocations of the Lambda function. The other issue, and this is really a big one, is that in order for the Lambda function to connect to the VPC, it needs an elastic network interface. And it can take up to 10 seconds to create that elastic network interface. Imagine a scenario where you invoke a Lambda function and it's trying to retrieve data from a database. It might take the Lambda function up to 10 seconds just to connect to the VPC. And then after that, it needs to communicate with the database and then provide a response back. And so that additional latency could have a severe impact on your application. Now, if you have to remember that there are cases where a Lambda function is going through a cold start process, and other cases where a Lambda that was previously invoked might be re-invoked again in a warm start situation. And in a warm start situation, the Lambda function already has a private IP address and ENI set up. And so a warmed up Lambda function will not incur that VPC attachment penalty. It's really the cold start functions that get penalized. This is really important to understand. However, when you're if anytime you're thinking about connecting a Lambda function to anything that lives within a VPC. Okay, well, let me kind of finish things off in this segment by talking about a number of best practices when building and working with Lambda functions. One of the best practices when working with Lambda functions is when 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 you create a Lambda function, when you write the code, you create a handler function, which is the default method that's invoked when the Lambda function is launched. And best practice is to separate that handler function from the core logic in the function, meaning that the core logic that you create in the function is going to be encapsulated within other methods and not within necessarily the handler method. The benefit of this is that it makes it easier to unit test the Lambda function. And, of course, we always want to write unit tests anytime we're creating application code. And Lambda functions are no different than any other type of application code. And we should be unit testing our Lambda functions. When you create the Lambda function, you also want to think about taking advantage of the execution context of the function in order to improve performance. Remember again that Lambda functions will go through a cold start process the first time they're invoked, and then after a Lambda function has been invoked, then subsequent invocations may result in a warm start of that Lambda function. We can kind of take advantage of the warm start functionality by using static constructors, global variables, and singletons within our Lambda function. So for example, if my Lambda function needs to set up a connection to a database, I wouldn't want to set up that connection to a database every single time the Lambda function was invoked. I would want it to set up the connection to the database the first time the Lambda function was invoked during a cold start, and then subsequent invocations, which might result in warm starts, those invocations would call the handler function, but if I already have my database connection set up, the Lambda function will not have to go through the process of creating that database connection again. If I've set up my database connection outside of the Lambda function, outside of the handler function, I've essentially made it a global or a sort of a singleton object. When you are creating your Lambda function, you can use pre-existing libraries that already exist in the Lambda environment. AWS always makes its SDK available in each Lambda function environment. For example, if I'm creating a Lambda function using Python, then AWS will automatically make the Boto3 library available, which is the AWS SDK library for Python. You don't have to specify, uh, the version of Boto3. You don't need to package it in because it's going to be available to you by default. This can be beneficial, but it could also sometimes be dangerous, especially if your function is relying on a specific version of Boto3. If that's the case, then if if you don't package that version of Boto3 in with your Lambda function, it's possible that your code may break over time as AWS, sort of continuously updates the version of the Boto3 library. When you're creating Lambda functions, you should always be thinking about performance and figuring out how to make your Lambda function more performant. Because of course, the more performant the Lambda function is, the lower it costs, and the faster your application will perform. And there are a couple different ways to make your Lambda function more performant. Uh, One way is by choosing the right framework and the right execution environment. Lambda functions that are, Python-based Lambda functions can oftentimes run faster than Java-based Lambda functions just simply because it takes longer for the Lambda service to bootstrap a Java virtual machine environment that's required to run your code. So there's sort of, there's certain Lambda functions like Java and .NET that are just sort of require more bootstrapping effort to get the function going. And if you do need to use a Java-based Lambda function environment, then you might want to be careful about what sort of Java framework that you're using in the function, because some frameworks are much lighter than others and more performant than others within a Lambda function environment. So for example, the Java Dagger framework might be more performant than using Java Spring inside of a Lambda function. Of course, you always have to be wary when you're using something like recursive code. It can and there's always a higher probability of running into situations where your code execution just runs out of control, and when you're using recursive code. So try not to use recursive code within a Lambda environment. There are cases where in your Lambda function, you're accessing other services and resources like databases, or you might be communicating with, something like a message bus, or some other service that you create. And especially in the case where you're using a traditional request response sort of pattern where your Lambda function is making a request to some outside service, and then waiting for that service to respond. And if that service, if it takes a few seconds to respond, then your Lambda function is just sort of sitting there doing nothing. It's running, but it's just sort of like in a spin wait cycle, waiting for a response back from that external service. And generally with Lambda functions, we don't want to be waiting for responses from external services, especially in some cases where you make a request to an external service and it's doing some heavy processing, and it might take a minute or two to respond back with a payload. That's really a bad situation, and a very expensive situation for Lambda, because Lambda functions represent the most expensive sort of computing that's available within the AWS ecosystem. So you don't want to create Lambda functions that are running for long periods of time. And if your Lambda function is making requests to external services and it has to wait a while for response, that should be a trigger for you that the Lambda function is maybe not quite the right solution for your problem, and you should be looking at an external orchestration solution like AWS step functions instead. That would be a better fit for that sort of scenario. I mentioned earlier that when there are cases where Lambda functions might connect to databases, and uh, you could inadvertently sort of um, you know overwhelm a database with demand in a scenario where you have hundreds of Lambda functions being invoked concurrently. So you might create a Lambda function that is communicating with the database, and 300 concurrent invocations of that Lambda function are launched. And so that Lambda function is trying to create 300 concurrent connections to your database. But maybe your database will only support 100 open connections at any given point in time. So you could sort of quickly overwhelm your database with connections from Lambda functions if you're not careful. So anytime you set up a Lambda function to talk to a database, you really need to, put some limits in place, and you can limit the number of concurrent of invocations of a Lambda function and make sure it doesn't overwhelm your database. A few more best practices here that I want to talk about. When you're configuring your Lambda function, you specify an execution role, and that execution role basically describes the permissions the Lambda function has when it's running in AWS. And I oftentimes see people when they're setting up Lambda functions, they select a really broad role that is super powerful and gives the Lambda function access to all sorts of resources in AWS, and that's really not a good idea. You should, when you create the Lambda function role, first of all, most cases you want to sort of create a custom role for that execution role, and you want to specify the most restrictive permissions possible for that role, so that the Lambda function only has access to the resources that it absolutely needs to access. Um, when you're when you're working with Lambda functions, let's say you create the Lambda function, you test it, and it works, your job isn't done yet. Once you get the Lambda function working, then you need to really figure out how to tune the Lambda function properly. And there's sort of two things that you really want to focus on tuning. One is the timeout value for the function. And remember, you can specify that a function should time out after 15 seconds or 10 minutes or whatever the case may be. You don't want that timeout value to be too short because you don't want the function, you don't want AWS to terminate the invocation of your function too quickly, especially if the function isn't done processing. But you also don't want the function to run too long either. So you want to set some sort of sane timeout limit so that the function is terminated if for some reason it runs longer than expected. And that's because if you have a really long timeout value set for your function, you might generate quite a few concurrent Lambda function invocations, and you could have these concurrency spikes that form because Lambda functions just aren't they're sort of running too long and they're not timing out properly. The other tuning parameter that you need to think about is the amount of memory that you allocate to the Lambda function. And sometimes the inclination is to give the Lambda function the least amount of memory necessary for it uh, to to function properly. But there are cases where if you give the function Lambda function more memory, then it's actually going to be less expensive to run that function because giving the function more memory will allow the function to process requests faster. So you have to think about this trade-off between giving the Lambda function more memory and the execution time, because it's the execution time multiplied by the amount of memory that really translates into the cost to run that Lambda function. And so it's not always really obvious as to what the amount of memory should be. And this is a case where you need to sort of iterate over and run a series of tests to try to determine the optimum memory value for your Lambda function.